Welcome back, hobbyists, brewers, distillers, friends, and the entire community. We're going to do a video today. Now, this may take a little while, so I may have to break it up into a couple different parts because we're going to cover a lot of information. But trust me, we're going to make this so simple. I just don't want anybody to miss anything and then have that uh-oh moment when you put together your controller, because that's what we're going to talk about today, controllers. And there are several videos that we have out, like, selecting the proper element for your whatever your process may be. So whether you're doing a brew kettle, whether you're doing a still, whether you're doing a bakelite oven, whether you're doing plastic infusion, we all know that in most of those processes, precise temperature control is very, very important. So we have a way to do that. We have precise controls. And the one that I work with most often, there's two actually. There's the PID, the proportional integral derivative controller. And I liken that to a cruise control in your car or your truck. It really is a fantastic piece of equipment. And now the other one that we work with, and we'll show you that one on another video, is the pulse width modulator. And that one's more of an analog setup, but when we get to that, I'll explain that to you. But they're both extremely, extremely precise and work extremely well for you. So now here's what I've learned in the past. I'm getting ready to build one because someone has a specific requirement. So when you have that specific requirement, and I'm going to explain to you what that requirement is, and then we'll go through and I'll explain why George picks the pieces and parts that he does to put this together. And then it all depends. I mean, I don't know how interested you are. I'm going to put this together. It's going to take me a couple of hours, but it's well worth it, and it's all therapeutic out here in the shop. So let's get on to what we're actually doing today. Now, we're going to build a PID, and the person that wants this PID wants it to, they want it to be 120 volts. So we're going to select everything for 120 volts. And we're going to run off of a 20 amp circuit. Now the 120 volts 20 amp circuit, and they're going to use a 2000 watt heater element, which is pretty standard. So that's what we're going to build this to. Now additionally, they want to have a switch so that they can plug in a water pump, a radio, a fan, or whatever the case may be, and they want to work that separately from the element switch. So they want the PID to operate the element, but they also want to have an accessory plug to plug into, and they want to be able to turn that on, turn that off. So we're going to also do that. So I'll show you that. And that's really, really simple once you get down to it. So now the selection of parts. Now this is the one that is very, very critical. Please comment below because we use those. And we appreciate it and we'll always answer. Now, don't forget to subscribe. Here it is. We'll have people call a lot of times, say, well, yeah, I've done everything, George. I followed the video because we got a wiring video, but it's not working. I can't get the solid state relay light to come on. Well, chances are, and in almost 9 out of 10 cases, the problem is actually the incorrect PID. And now I've gone through this before, and I'm going to go through it again, because you really, really need to understand this. And this works for all PIDs. Now, PIDs are made by, my favorites are MyPin and Inkbird. There's Rex makes one. That's a Chinese knockoff model, but it's only in Celsius, so you can't adjust it and let it read out in Fahrenheit. Altonics. There's many, many makers, but they all have the industry standard of the models that they make. So let's dive into this and I'll explain it to you. The Inkbird, and I also like the MyPin. Now they are both equal products, and again, depending on where you get them, they'll run you anywhere between $30 and $32. Depends on what, again, who you order them from. Amazon carries them for anywhere from 30 to 32, 34 bucks. So it's up to you. Now here's what's so specific about that. You can get tripped up because MyPin also provides this one, which looks exactly the same as a TA4. Both of them are TA4s, and you'll see that It says a model TA4. This says a model TA4. But there's a difference. This is an RNR. This is an SNR. Now this is the critical link. Is that, first of all, this one's only going to run you about 24 bucks. So you're going to save 8 to 10 bucks. Now, whatever the case may be. So a lot of people will just select this one. But I've already outlined this. I've circled it in black. It says output relay. Now we're going to be using a solid state relay. So, and that's because of the amperage, the power that's going to be running across pins 1 and 2. See, this will take 24 to 380 volts of AC. And it's got a 3 to 32 volts of DC input. And there's your little red light that comes on when it's activated. It connects those 2 pins. So we're going to be using a solid state relay. Unfortunately, this says output relay, and that'll trip you up because this is not a solid state relay. This is an internal relay, and it's only rated at about 0.5 amps or 5, I think, no, it's not even 5 amps. It's 0.5 amps at its rated value. So if you try to use this as the internal relay on the PID, you'll burn it. So this is for a small operation, and you're going to use the internal relay in the PID. So you don't want this one, although it's cheaper. You want this one. This is the TA4 SNR, and you can always tell about this because you look here, it says output SSR, solid state relay. So that means the output pins from this PID are going to control this solid state relay on pins 3 and 4 to activate it so that pins 1 and 2 are connected, and we'll get to that. So this is not complicated, trust me. It's going to cost you a couple of extra bucks, but it's going to save you some headache in the long run. Too many people have purchased the RNR just to find out that after all that work and effort, they've got to either return this or chuck it, store it somewhere, and just buy the SSR model. Okay, now Inkbird does theirs just a little bit differently, and what I've done here is I've also circled this one because you can tell by the model number. And this is the model number is the ITC 106VH. And it's 100 volts to 240 volts input. Then it says quantity, 1 piece. We got one of them in here. Now, this is where the instructions come in handy. And I know sometimes the instructions can be really, really confusing. But if you look down here, it'll say the ITC 106VH. That's the model number. That's this. And it's a solid state relay output, SSR. And its supply voltage is 100 to 240 volts. And that's what we want because we're going to be using 120 volts. Now, I've had folks that have called in and we found out that they have actually got the RH model. And you'll see here it's a relay output. It'll handle the input voltage of 100 to 240 volts, but it's a relay output just like the TA4 my pin. It doesn't operate a solid state relay. Now I've got 2 of these, and what I have here, these are the solid state relays. And most of them made by Photech. Some of them are made by Inkbird, makes them. A couple of different companies make these. And this one says solid state relay -25DA. So that's a 25 amp relay, and we're going to be operating 120 volts with 2,000 watts, and we already know if we did the math it would be about 16.6 amps, so this one would be sufficient. Now if we're going to run 240 volts or we're going to be running a larger heater element, I'd probably use the 40 amp solid state relay. Now they both look exactly alike with the exception of the 25 or 40, and the 40 amp is a little bit beefier, so you'll be able to tell the difference if you put them side by side. The 40 amp looks a little bit larger because it'll handle more amperage going across pins 1 and 2. All right, that's the next piece. It always comes with, in most cases, it will come with this heat dissipator. And this just goes inside, and this is where your solid state relay sets on so that the heat can transfer through this and these fans and keep it cool because they do heat up. In order to aid in the heating of these PIDs, I use a small, this is a 50 by 50 millimeter by 10 millimeter deep. It's a 12-volt fan, and these run about $3. Now you can get a 120-volt fan, but unfortunately they're going to run you anywhere from 30 to 60 bucks. It all depends, again, where you get them from. But these are kind of like dirt cheap. They're actually computer pieces, computer parts. They go in the back of computers, you know, some of your desktop computers. But it's a 12-volt fan, 12-volt direct current at 0.7 watts, which is a really, really low drawing fan. So now, but we do know that we have 120 volts going in. We don't want to use 120 volts to operate this fan. So what we want to do is we want to drop that down to 12 volts. So I went to Meanwell. You go to meanwell.com, and I got one of these transformers. This is a integrated circuit transformer, and here it's the IRM-10-12, and that -12 means it's a 12 volt. And so what I'll do is, I'll see these pins on the back, I'll just solder my connections on the back here, and I use anywhere from 18 to 22 gauge wire because it's a very, very low amperage draw. It draws in 120 volts, and you have a neutral. It's AC-N and AC-L. That's the load and the neutral, so the black and the white. And then on the output, you have positive and negative. And that is polarity specific for the fan. So what I'll do is I'll use a couple of jumper wires, and I'll jump from any 120 volt circuit that I have inside the PID, either from the PID, from where it comes in the box. I'll use a little bit of super glue, and I'll glue that to the bottom of the box so it just stays there, it stays firm, and then I'll connect the fan to this so that when this turns on, the fan turns on. All right, the next piece is I have a couple of options here. Here's a lighted switch. This is a rated 20 amps, a lighted switch for 120 volts or 240 volts at 10 amps, and I've got the unlighted switch, but it's a lighted switch, so this one, just like this one, is a ground. So you'd put your hot, and a ground, and then when you turn the switch on, this light would come on the switch. Now this one's not a non-lighted switch, but it also has the ground there. So keep that in mind. And if it comes with only two, all it is a switch just like you would use in your household. You'll have hot wire going in and hot wire going out, and then the switch connects those two. So that's the next piece. Another connection that we make is for the thermocouple, and that is the temperature sensor. And it's a K-type temperature sensor, and you'll know the thermocouples. You'll know that it's a K-type directly when you see only two leads, a red and a blue. Red's positive, blue's negative. What we'll do is we'll put this plug inside the box, and I'll show you where that goes, and it's polarity specific, and they're marked positive and negative. You just put the wires here and here, and then we have the plug itself. You'll unscrew that, and inside here you'll have a positive and a negative, and that's where there we go. You'll have the positive and the negative, and that's where you'll connect your thermocouple. And this being polarity specific can only plug in one way. You can't plug it in backwards, which makes it really neat. It only goes in one way, and when you plug it in, it makes the connection. You can actually skip that and just wire it directly to the PID, but I do that so that you can store it. All right, I did this last time. I went this thingamajiggy right here, and what this is just a method for getting the wire from outside to inside the box. Your wire goes in here, and this is a collar that goes on the outside and holds it. I'm going to use 14 gauge wire, and I just picked up this roll. These are what, $8-9, and they're for power. They're power cords for power tools. So we brought that. Now, here's an option for you. I've got these small square plugs, and these small square plugs, you can find these on Amazon. They're just receptacles. And what you do is you cut the 1-inch hole, square hole for it to fit in, and then when it slides in, it clips, and it'll hold fast inside your box. And then these knife blades on the back is where your wires are connected to. Right here, you've got a ground, a hot, and a neutral. And once you put that on, it comes with the back piece that slides right on it, And when you close that, it only goes on one way. It'll snap in place and seal and hold the wires in place, and therefore you've got a plug. Now you have that option, or you can also, and I picked these up from the local hardware store. This is a 20 amp, 125 volt rate. Whoa, there were a 20 amp, 125 rated receptacle. So it has your brass side for your hot wire, and it's the silver side is the neutral wire. And if you'd like to, because it's real simple, you can replace the lighted switch with just a straight switch that you would use in the house. Because all you do is a hot wire goes here, and a hot wire goes there. And every time you flip this switch, it connects these two pins, and it provides the power to whatever it is you're trying to control. Off. There's your ground plug. Now we're getting down to the nitty gritty here because this is really great. Of course, if you use this, you know, these are your plates. You pick up a plate, however you want to put it. You can actually put these two side by side, and you can actually wire it so that this switch only operates the bottom, and the PID controls the top, or vice versa. Or you can use this to turn on the entire process, the entire system. It's totally up to you. Now, the one other thing that we do have is the box. Now, these are the boxes that I use, and people always ask about the size of them. It's, you get it like this. It's 4 inches deep, 6 inches wide, and it is about 8 inches long. Now, most of this stuff comes in sizes in millimeters, and just convert millimeters to inches, inches to millimeters, but it all depends on where you get these from. But this one is, yeah, it's rated millimeters, but those are the American measurements or the industrial measurements. So it's 4 by 6 by 8, and that's plenty of room. You can actually go smaller than that, but that's plenty of room. Now, I also have a little bit of what we call thermal grease, and what the thermal grease is for, it goes on top of my heat sink. I'll put a line of thermal grease here, and then I'll place the solid state relay on there, screw it down real tight, and that just makes a solid connection between the solid state relay and the heat sink so that heat does transfer evenly and equally. Now, I believe I've covered just about everything that you're going to need. Okay, now I believe I've covered just about everything you're going to need in the pieces and the parts. Now I'm going to explain to you why the selection of these parts is pretty direct and straightforward. Well, first of all, the box is just large enough to fit everything, and also it's large enough where I can draw ventilation holes so that the fan does its job, and it just keeps it cool. I'm going to select the 25 amp solid state relay because I'm at max use with a 2000 watt element. I'm only going to draw 16.6 amps. So this will be plenty for it. And again, if I was doing something larger, I'd use the 40 amp. So we'll set that aside. I am actually going to insert the my pin, TA4 SSR, but the model number is TA4 SNR plus K. And plus K means the K-type coupler that we talked about earlier. So I'm going to put that in there. Now I'm also, you know, I'm going to use this for my coupler. This is a plug that goes in there. This, and I'm going to add 2 of my small square receptacles, and one of them will be operated by a switch, and I'm going to use the other switch to turn on the entire system so that the PID lights up and it's ready to go. Now, that's why I've selected those pieces, and those will serve you well in the very near future or in the distant future. So for all of this, I'm going to put this together. This is going to run, you know, again, it all depends on where you get it from. So you can do it for less than probably, I'd use an average of about $100. But the freedom and the precise control you get over your process is priceless. Now, make sure you watch the video on setting the parameters on the MyPin, because you preset the parameters and then use the auto tune function after you get it running to fine tune those parameters. So I guess what we'll do is we'll stop here, and I'll get the next video started, and that one's going to be on actually putting this together. And it's not that difficult, but it's tedious work, that's all. Well, look, until next time, and as always, whatever it is you do, if it makes you feel good, please do it as often as you possibly can. Happy brewing.